So what happens if we drop a nuke into the depths of the Mariana Trench for a good and proper kaboom?
You're about 550 kilometers off there, mate. Also, I doubt the Earth will giggle if you tickle it a little bit. Здравствуйте, skeptic squids, kakla. I really hate these viral chasing clickbaity channels, and Riddle is no exception. Squidmaru told me about a particular video featuring the Mariana Trench and nuclear explosions. Enjoy.
What would happen if a nuke went off in the Mariana Trench?
It will contaminate and destroy the hadiopelagic ecosystem, and make a few whales sad in the process.
This is the Tzar Bomba, the nuke that Soviet leader Nikita Khrushchev promised to show the West during the Cold War.
The Tzar Bomb was a 27 metric ton, 8 meter long thermonuclear device. Similarly to other hydrogen bombs, it uses a nuclear fission primary which compresses a thermonuclear stage until fusion occurs. This creates a rather large explosion. This is also not really related to the actual video.
58.6 megatons of sheer, unadulterated power.
58.6 megatons of what? Did it weigh 58.6 megatons? This is a clear sign that the people who made this video have no idea what they're talking about. The explosive yield of a thermonuclear device is measured in tons of TNT equivalency. If you hear a particular bomb has a power of 25 megatons of TNT, it literally means it would take 25 million tons of TNT to create an explosion similar to that of the particular bomb. You're also factually incorrect. It was 50 megatons worth of TNT according to the Russian documentation, not 58.6 megatons. I'm pretty sure you just pulled that number out of your ass or something.
And this is the Mariana Trench.
No, that is not the Mariana Trench. Did you just go on Google Earth and just type in Mariana Trench and click search? Oh wait, that's exactly what you did. You see this particular feature right there? That crescent-shaped feature that's quite clear, quite obvious, quite striking? That is the Mariana Trench. That. You following me? You see that little spot right there? That is Challenger Deep, the deepest part of the ocean. Are we on the same level now? Of course we're not. Of course we're not on the same level.
The deepest crack in the Earth's surface.
Is it called Mariana's Crack? No, it's not. It's called Mariana's Trench. It's what happens when you have a tectonic plate subducting underneath another tectonic plate. The Mariana Trench is part of the Isobonan-Mariana subduction system where the Pacific plate is being subducted beneath the Mariana plate. This is a perfect example of island arc formation and volcanism.
A canyon almost 7 miles or 11 kilometers deep, up to 3 miles or 5 kilometers wide, and completely filled with water.
As opposed to what? The tears of geologists that sit through this horrible video. Of course it's filled with water, it's under the ocean.
The Tzar Bomba was dropped from a height of 6.5 miles, that's about 10.5 kilometers, which is almost equal to the depth of the Mariana Trench. Coincidence? I don't think so.
The bomb was dropped from 10.5 kilometers, yes, and the deepest part of the ocean is just shy of 11 kilometers. Could it be that the Soviets were planning this all along, and they were testing from how high they can drop the actual bomb, disregarding the fact that the trench is nearly 11 kilometers below sea level, and that the very idea is ridiculous? Or that the Tupolev Tu-95, the plane that dropped the bomb, had a service ceiling of 13.7 kilometers max, and it was carrying an extremely heavy load, so it can probably only reliably fly about 10.5 kilometers, and the fact they were trying to fly as high as possible to not get blown up by the bomb they're dropping.
So what happens if we drop a nuke into the depths of the Mariana Trench for a good and proper kaboom?
You're about 550 kilometers off there, mate. Also, I doubt the Earth will giggle if you tickle it a little bit.
Alright, so we've decided to blow up the Mariana Trench.
No, you've decided to blow up a tiny bomb in an otherwise very large geological feature.
After all, the density of water is 1 gram per cubic centimeter, which means that at these depths, the water pressure will reach 110 megapascals, which is 1100 times normal atmospheric pressure.
Your editor should be taught what scientific notation is and what prefixes to use. The number you just put up says 110 million megapascals. That is 1.1 times 10 to the power 14 pascals, or 110 terapascals, which is about 1.8 billion times atmospheric pressure, or roughly 10 times the pressure at the center of Jupiter. In reality, the pressure at the bottom is 108 megapascals, roughly 1,000 times standard atmospheric pressure. I've no idea where you get the 1,100 figure you just showed.
For our purposes, this means that a nuclear bomb with the standard outer layer of lead will simply get crushed flat, without detonating, of course.
Now, I'm no thermonuclear weapons engineer, but I've watched enough of Scott Manley's videos to know they're not constructed out of lead casings. Even if they were, they would not be crushed flat like in a hydraulic press. That's just not how physics work. If the bomb is not sealed, water might leak into it, and the water pressure on the inside and the outside will equalize. If the bomb is sealed and weak enough, it could eventually rupture, and water can get inside, equalizing the pressure on the inside and the outside. At the very least, you might see something like this happen.
The amusing but lackluster end result would be a giant uranium pancake. This pancake will emit radiation for centuries, as the half-life of uranium is 2,000 years.
2,000 years? Are you serious? Uranium-235, which is usually associated with nuclear bombs, has a half-life of 700 million years. It's literally the first thing you see when you Google search it.
But in this scenario, there will be no explosion. The charge won't be compressed to the point of critical mass, and the thermonuclear shell of the bomb will get torn off halfway to the bottom and dissolve in the water. Dissolve
in the water? What do you think nuclear bombs are made out of? Paper.
So let's say the bomb will be lowered down inside a bathyscaphe. In this case, we're gonna get our bang. If the bomb is detonated at a depth of between 3 to 5 miles, that's 5 to 8 kilometers, the explosion won't be that much different from your typical underwater nuclear test. Oh, except for a tsunami 400 feet or 122 meters high that will appear on the surface of the Pacific Ocean.
This is utter nonsense. The Baker nuclear test at Bikini Atoll made waves 1.8 meters high, around 6.7 kilometers away from the source of the explosion, and the explosion was only 50 meters deep. Even though the Tzar Bomb has 2,500 times more energy, the effects don't scale linearly. You're also suggesting the bomb be detonated 5 kilometers deep into the ocean. It has to expend a lot of energy to push all that water away. Let's assume that a 20 kiloton worth of TNT explosion creates a 2 meter high wave at about 7 kilometers away from the center of the explosion. The explosion yield is proportional to the amount of water displaced. The explosive energy is measured in joules, and the amount of water displaced is measured in volume, or meters cubed. Now, if we make this model extremely simple, and I really mean super simple, we can say that water equals P to the cube root of the explosive yield. Calculating the proportional constant and plotting the graph, and then using 50 megatons as yield, we see a value of about 26 meters. About 100 meters less than the figures you showed. Please keep in mind that this model is extremely simplified. It doesn't take into account, for instance, the interaction of the explosion shockwave and the oceanic crust, and also doesn't take into account of water changing into steam, as a lot of energy will be lost in the process. From research done by people way more qualified than me, it's pretty clear that explosions underwater, or nuclear explosions underwater, lose energy extremely quickly, further pointing to the fact that the amount of destruction they're showing in this video is grossly exaggerated.
And completely wash away Japan and all of Southeast Asia. Also, half of Australia and the eastern regions of China will see tremendous flooding.
Again, this is assuming the physics of this wave is similar to conventional tsunamis. It isn't. The shockwave is absorbed by the oceanic crust, mitigating surface level destruction.
2. If the bomb is detonated at a depth of between 5 to 7 miles or 8 to 11 kilometers, or at the very bottom, then we'll have to take into account the fact that the Mariana Depression is located at the boundary between two tectonic plates, the Pacific and the Filipino.
No, it's not. The trench marks the boundary between the Mariana Plate and the Pacific Plate. Also, what are you showing there? It looks like a Google image superimposed over something that resembles cracked mud. This scale is just completely wrong. You're overlaying the entire Pacific Ring of Fire over a part of the seabed that's not even the Mariana Trench. It's just embarrassing. This video is getting way too long. No one wants to watch a 40-minute video of me rambling about silly physics in some dumb YouTube channel. This is the end of the first part. The second part is going to come out eventually. Just stay tuned for that. If you really enjoyed the video, please do like, please comment, and most important of all, please subscribe. Enjoy the rest of your day. The Tzar Bomb was a 27 metric ton, 8 meter long thermonuclear device. Similarly to other hydrogen bombs, it uses a staged approach. The primary nuclear fission stage explode. The Tsar Bomb was a 27 metric ton, 8 meter long thermonuclear device. Similar to other hydrogen bombs,